the final board is another CPU board. And I really don't get it. I mean, if you make, if you have a CPM machine with a Z80 CPU, that is more than sufficient to do Telex. I mean, the Telex standard is really, really primitive. So why they need another CPU board, I really don't know. But it looks like a co-processor or something like that. This board here has an enormous TMS 9900 CPU. This is a 16-bit CPU from Texas Instruments. And it was really, really powerful. And next to that, they have another TMS 9901. This is a support chip for this one. And apart from that, they just have a massive amount of memory. RAM and ROM, and that's it. Really weird. On top of that, they have a real-time clock and the battery out here, which is still fairly okay. One or two traces down here are starting to corrode. They are very sticky. So I have to remove this battery. But otherwise, the board is still fine. But yeah, why would you want to have a co-processor in your machine? It doesn't have a floppy drive, it doesn't have a VGA, it doesn't have anything. It just have a port in here to the back panel, and a little connector here with a cable that goes to that goes to I don't know where it goes to. It doesn't go to anywhere. I didn't pull out any cable from here. So basically, the machine is a CPM machine. It has a complete CPM hardware, including floppy drives and a VGA output, video output. And it can do anything that a Z80 CPM machine can do. It can run business applications and everything. And then they have two massive serial port PCBs and an enormous co-processor. Why? Any ideas? Comment below, because I really have no idea. This is a very strange design, really. Very strange. But otherwise, I mean, it's really very nicely done. You can see the main board here. The layout is very nice, two-layer board, and yeah, very beautifully done. You can see that it's a early 80s design, but otherwise it's very well done. Double-sided board, done with some kind of CAD system. It's definitely not laid out by hand. So yeah. A little botch wire here, but that's it. So very interesting, very interesting. Now the only thing left really is the Telex modem itself, and that is why this machine is caught my interest. As you can see, this is a complete final unit, and it has been inserted into the rack system like this. And I think there are two reasons for that. Obviously, the first one is that this is a final board. It has already been type approved, so you don't have to go through all the type approval stuff again. So you just mount it in your machine. Also, when you're a system integrator, you just buy modules and plug that in, and that's it. But the interesting thing is this is done by ATS Communications, so they could actually just take this PCB and mount into the box. So the reason for doing it this way is definitely type approval. You don't want to mess with the type approval product. And that also explains why on the back of the main enclosure, the cable just pops out through a hole there. There's no connector or anything, because the type approvals wise, this is the way to do it. British Telecom was very, very strict with their type approval until very recently. And in fact, I used to be a ALE, liaison engineer for British Telecoms, which means any factory that wants to manufacture BT approved equipment, they need to have an engineer on site that represents British Telecoms in case you want to make safety critical changes to the equipment. But anyway, let's try and open this one up and see how that is made inside. This is a standard box, of course, and it looks like something that was on sale in Mablin in their catalog, if you remember that. Very standard box. I think I've seen some Sinclair Spectrum accessories in the same enclosure. It's not a bad box, but it's probably not very cheap either. So yeah, this is where it really gets interesting. I have no idea what is inside. I have never seen washers all over the shop. I have never seen a discrete Telex modem before. Telex is basically a 100 baud modem, so it's very slow. So there could be just a modem chip and some interface stuff in here. Yeah, let's have a look. So yeah, very interesting design, and I was completely wrong. There is so much in here. So basically, it's a complete modem. It's just not the audio to digital interface. It's a complete modem. It has a power supply, obviously. We have a massive transformer here and the voltage regulator down in this corner here. What have we got? 8085, this is the CPU. We have 8155, this is a glue logic. And some memory. And an 8251, this is a serial port chip as far as I know. So this board is the digital board, and that's really fine. I mean, that is the way to do it if you want to do it like that. But yeah, it's a complete modem. You could sell that off the shelf like this. So it would have a serial port coming in here, and you would send it AT commands or something like that for controlling the modem and setting the different states and parameters. Fairly nice, no big problem. And of course now we have to look at the analog part, which is in the top of the enclosure. So here we have the electronics for the analog part, and as you can see, there's a cutout here where the transformer is supposed to be, and then we have all the electronics on the left side, and we have the telephone interface on the right side. And British Telecom was very hysterical with this kind of equipment. It's connected directly to the phone line, not using an acoustic coupler or something like that. But connected with a cable like this directly to the phone line. So they were very scared that you blew their line or something like that. So we have the phone line interface itself, and it's isolated from the electronics using a big transformer. And there were companies like ETEL in the UK who did nothing but make transformers that were compatible and safety compliant to the British Telecom standards. I mean, British Telecom was so difficult compared to other telecoms in the world. But anyway, we can see that in the PCB. We have basically 1 centimeter of clearance all the way through here, through the transformer and out. And also the relay itself, there's a relay for going off hook or on hook, for going on hook and off hook. And if we take a look at the relay, the distance between the coil and the contacts is also about 1 centimeter. So it's really ridiculous. But anyway, we can see this is a wet design. The DC current flows through the transformer. In later designs, the transformer was reduced a lot, and then only the AC would run through the transformer, and the DC would run through some transistor network that would emulate an inductor. But anyway, that is not what we're going to talk about here. The control signals comes from the bottom board, from the CPU board, through this connector. It's the transistor for driving this relay, and then we have some serial stuff going this way through here. Okay, so if we look at the electronics here, this is basically the entire modem, and it's pretty well made. So here we have the modem chip. This is a Motorola 14412. This is a modem chip that can handle speeds up to 600 bits per second. But of course, for this application, we are running at 100 BPS. But anyway, this is the modem itself with the clock frequency next to it. We have a bit of logic. And then we have these 3 chips here, which are very interesting. These are MF10CN from National Semiconductors, and these are switched capacitor filters. And that was something that was in when I went to university. Before signal processing really took off, before the DSPs became available from Analog Device and Texas Instruments and stuff like that, switch capacitor filters was what was used. So there are 3 of them, and I believe 2 for receive, 1 for transmit. I think that would be a good guess. But yeah, a lot of analog stuff, and the modem chip and the signal, the RX and TX would then go to or come from this little connector out here. So yeah, really standard design, and I'm sure it would work great today as well if we had a telephone line, which we don't. But yeah, otherwise, really well done. So yeah, it turned out that this machine was for land-based telex and not for maritime. But still, quite interesting. We've seen a 100 baud modem for communicating over the phone line, and we've seen a very interesting piece of hardware with a dual CPU, one Z80 CPM machine, and a very high speed, very powerful for that time, Texas Instruments TMS-9900 CPU as a coprocessor. So yeah, I still don't know what that coprocessor board is for. So if you have any idea, leave me a comment. But anyway, thanks for watching, and see you again later.